Hello everyone, good evening.
Hello, sir.
Okay, so today we have open session for week 10. So before that, how many of you have gone through week 10 content?
Sir, only first 3 or 4 videos.
Okay. What about others?
Yes, sir. So far, I've finished watching and have done
So
all
gone
the
all of
activities and
the
practice.
videos and tried a practice assignment.
Okay. Okay, so we will go lecture by lecture and let's see how things are going. Okay, so yeah. So in the week 9, I hope you all got the idea of what random variables are actually, right? In first, I think in week 7, 8, we have computed probability of some events, right? And week 9 also we
Yes,
are
sir.
doing the same thing, but now we are defining those events in terms of some random variable, right?
Yes, sir.
Okay, starting with that. So expectation of a random variable. So any confusion in that part, or is it clear?
So it's clear.
Okay, any doubt in
Yeah,
any
it's
of
clear,
these
sir.
activity question?
No, sir.
Okay, what about properties of expectation? Is it clear, or any doubt in any of it? Okay, which part you are struggling the most in week 10?
So the property of variance where the constant is multiplied. Like there are few questions in the practice assignment
Mm-hmm.
where they are not squaring the constant while we are multiplying it.
Okay, do you recall which question is it?
So the 20, yeah, this minus 2x plus 3.
Minus 2x plus 3. Okay, where is it? F.
This one, sir. Below this, below. Yeah,
This
this one.
one.
Yeah. And apart from that, we know that expectation of any constant is 0. But here we are taking it as 3.
Okay, expectation of any constant is 0, or is it the constant itself?
So while we were, while I was going through the activity questions,
Okay.
so there was one question where they were taking it as 0. Like
Okay.
the expectation of k, where k is the constant. So they were taking it as 0.
Okay, do you recall that question? Which question is it?
So, like I won't be able to recall it like this.
Okay, we will cover that thing also. Let me just. Okay, we will cover that question in that case. Okay. Okay, any other thing except that?
No, sir, just that.
Okay, great.
Sir, just one thing.
Yeah.
So if you can discuss one thing. I mean, the conversion. Conversion thing means in word problems, there are some confusions, like how to approach a particular question. For example, there was a question like bonus. I've done that, but it took me like 2 to 3 minutes to just approach that question in a right way. I mean, let's say the standard deviation is given and all that, and some questions we are just converting it to variance and then calculating, and sometimes we are just taking the standard deviation thing and just using the property of standard deviation. So, sir, if you can just clear that part. I mean, for which thing we should approach in if it's standard deviation given, we are going to calculate using standard deviation, not converting it to variance and calculation. So if you can just clear that thing.
Okay. Okay. Yeah, that part also we will do. Okay, great. Okay. Okay. Before that, okay, the first question was expectation of a constant. Okay. What is expectation in general? Like, what is your understanding of expectation of a random variable? What does expectation of a random variable tells you?
So expectation of like random variable giving out any value.
And what does that value
Like
mean? Like,
if we are trying to infer something from the data, so we'll look into the probability and guess what is the expectation of this thing happening.
mm, okay, okay. Let me just give you an example. Suppose my random variable can take three values. Okay, 1, 2, and 3. Okay, and with some probabilities, let's say P1, P2, and P3, and obviously they will all add up to 1, right? Now, if I say that expected value of this random variable is 1.56, what does this 1.56 tells me?
The expectation of like what are you defining X as? Like
Okay, okay. Let me just. Okay, so do you know what is expectation? Is just a long run average, right?
Yeah.
Long run average. Okay, so long run average. Okay, so let's suppose it means there is some experiment you are performing. Okay, some random experiment, and your possible outcomes are either 1, 2, and 3, right? So suppose in the first trial of an experiment, I got outcome 2. Then in the next one, I can get 1, right? Then again 1, and again 1, then 3, and so on. You did it like large number of times, close to infinite times. Okay? And if you take average of all these numbers, the average of all these numbers, it will be equal to this value, 1.56. That's what expectation of a random variable tells you. Okay. Or in other words, like this is the basic conceptual definition of it. If you look at it from the formulation perspective, so if you recall, how do we compute expectation? It is just a sum of value what that random variable takes times the probability of occurrence of that value of random variable, right?
Yes, sir.
So basically it is nothing but, you cannot say another term, it is just a weighted average. Weighted average where weights are just your this probability. Okay, let me, I think, okay, so if we expand this, okay, for a moment, let's say my P1, P2, and P3 are all same, so they all will be equal to 1/3, right? In that case, your expected value would be simply the mean of the 3, right? 1 plus 1 times 1/3 plus 2 times 1/3 plus 3 times 1/3, which is nothing but 1 plus 2 plus 3/3. This is simply the mean, right? But
Yes, sir.
in practical life, you won't be having the same probabilities. There might be some case when you have, let's say, P1 has probability of 0.1, P2 is, let's say, 0.8, and P3 is again 0.1. So while computing the average, we need to make sure that my value 2 gets more importance as compared to the other two, right? So in that case, we compute average. Average is just another term you can use for expectation. It would be 1 times 0.1, where value 1 gets the weight according to the probability of its occurrence. The value 2 gets the weight according to the probability of its occurrence, and same for value 3. So in that case, you might get some 0.1 plus, you get the value 2, right? But here, if you do, it would be 5, 6. Okay, it's, is it same? I think so. 3, 5, 6. Yeah, it's also coming out to be same in that case. Okay, so it might be in that case, but if I give more importance to, let's say, 1 instead of 2, then you might get some other answer. Let's say 1 has the maximum chances of occurrence, so in that case it would be 1.3, right? It will go more towards 1 because one value is having the more weight, so it will definitely affect your average value. In the last case, we were getting 2 because the value 2 is having the majority of the weights as compared to the other 2, right? So expectation is nothing but the average which also takes into account the chances of occurrence of that event. Okay, now suppose I have a constant, right? Okay, suppose in this example only, right? So okay, let's say my x can take value 1, 2, and 3, right? And now I modify my random variable as x plus 3. So the possible values for x plus 3 would be, if x is 1, what would be the value of x plus 3?
4.
4.
4. For 2, it would be 5. These are the 3 values it can take, right? So now if you compute the expected value of it with the same probabilities, value of getting 1 is 0.8, getting 2 it's 0.1, getting 3 it's 0.1, it's gonna be 4 times 0.8 plus 5 times 0.1 plus 6 times 0.1, right? Which is nothing but the same expected value in which the constant gets added. Okay, it's x plus 3. If you want to know why this happened, so you can look, if you look at the formulation perspective, right? So now I am finding expected value of x plus 3, right? Which is nothing but summing over all the values of x plus 3 times the probability it takes that value, right? So if I open the summation, it would be x times the probability plus summation 3 times the probability. So if you recall, this is nothing but expected value of x, right? Plus this 3 is your just constant, right? And you know, if you add up all the probability, it should add up to 1. So it would be 3 times 1. So in general, what we got is expected value of x plus 3 is nothing but expected value of x plus 3. So from here, you can also conclude that expected value of a constant is the constant as well, because if you take the average of that one constant number, if suppose I have 3, if you take the average of 3, suppose you got 3000 times, right? You take average of it, you will still get 3, right? So average of a constant is the constant itself. So that's why expected value of a constant is that constant value only. Is it clear or any doubt in it?
Yes, sir.
Okay. 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 The next thing was, I think, standard deviation and variance thing, right?
Yes, I mean the approach stuff. I mean, according to the question, it's very confusing sometimes.
Can you tell me the question which you were referring to?
Give me a sec. Because see, I have written the question. I gotta find it. Otherwise, I need to refresh. Then, 2 minutes.
But do you recall any, like, what type of question it was?
It was a bonus kind of question. I mean, yeah. I can tell you the basic stuffs. I mean, the values, so you can just
Yeah, that would be great.
like
Yeah.
just to structure the question. So there were 2 persons, and
Okay.
someone bonus was 20% of the others, and like one person's bonus, one person standard deviation was given at the bonus. I mean, the random variable they took, that was given 1,000, I guess. I don't remember exact the number. So I mean, B's standard deviation is given 1,000 for the bonus, and
Okay.
A's bonus was 20% of B. So what is the total? No, what was the standard deviation of A? That was the question in the practice assignment, I guess. That was the question.
Okay. It's in practice assignment, right?
Yeah.
Okay. It's something referring to 1,000. Okay. Let's see. This one.
Yes, sir. Yes, sir. This one. Yeah, 1,000
Okay.
to 20%. Yeah.
Okay, so you know that Rohan Diwali bonus is a random variable with some standard deviation 1,000, right?
Yes. Sir.
Okay.
Yes, sir. Yes, sir.
Okay, let's just write it down a bit. Okay, so let's say Diwali bonus for Rohan is denoted by this random variable x. Okay. Diwali bonus. Okay. So this is referring to Rohan, right? Rohan's Diwali bonus. Yeah.
Yes, sir. Yes, sir.
And we know that standard deviation is 1,000, right?
Yes,
Okay.
sir.
And the second was Jyoti's Diwali bonus, right?
Yes, sir. It was 20% of Rohan's Diwali bonus.
So 20% of Rohan's Diwali bonus, it means it would be 2/10 times this random variable, right?
Yeah.
Okay, and you need to find the standard deviation, if I'm not wrong, let's check standard deviation of that bonus, right?
Yes, sir.
Okay, so how did you approach this one? Like, how did you started it?
Sir, it took me some time, but what I did is like standard deviation of x is 1,000. So I
Right.
just took 0.2 into x, and I just multiplied that in like that, like taking 0.2 out, and standard deviation, it's like not squaring, it's just it's the constant coming out. So I just multiplied 1,000 by 0.2. So just like that I did, but it took me some time. So I just want, like, the way we should approach it in this way, or sometimes it variance. I mean, it's all about timing, sir. That's why I'm just asking you.
Okay, see, it's really simple. Okay, so you need to find standard deviation of this variable, right? 2/10 times x, right?
Yes, sir. Yes, sir. Yeah.
It is
Yeah.
nothing but square root of variance of 2/10 times x, right?
Yes, sir. Yes, sir.
Okay, so square root of it would be 2/10 square times variance of
Square
x, right?
variance of x. Yeah.
And so this 2/10 comes out of square root, right? So it's squared.
Yeah, and that's the standard deviation of x under
Standard
root of
deviation
x.
of x, right? So that's how
Yeah.
you can
Yeah.
simply proceed. Just
Oh,
start with what's given in
okay.
the question, right?
Okay. So I don't need to calculate the variance. I mean, it doesn't matter what is actually happening over there. I just need to
Yeah,
structure it in such a way that I want.
yeah, just structure
Okay.
it as per your requirement, because standard deviation and
Oh.
variance are both are linked. So it is
Mm-hmm.
also possible that another way you can do it is you first compute variance of x, right? That would be some
Yeah.
1,000 squared. Then you find variance of 2/10 times x. So it would be 2 squared by 10 squared times 1,000 squared. Then you solve this value and then you compute standard deviation. So that's also right. But from times perspective, I will go by this approach, right?
Okay.
Which would be a bit lengthier one. So
Okay,
yeah.
sir. Got
Okay.
it. Got it. Thank you.
Okay. Yeah. Anyone? Anything else? And yeah, tomorrow you all are having revision session for week 7-8 by Professor Usha ma'am. So please do attend it. Yeah.
Sir, activity 10.3, question number 3 and 4.
Activity 10.3, question number 3 and 4. Okay. Okay, so how did you approach this one? It's a bit calculative one, I think, for now.
Sir, I cannot understand what's the probability of the expectation variable, sir.
Probability of?
Probability of expectation value, sir. It's like 0, 1, 2, 3.
Okay, so expectation is just a number, right? So how will you find the probability of expectation? Okay, I will just give you a hint on it, so you can just go through it and try again. But if we don't find probability of expectation, just be careful on it.
So for this, the random variable would be the number of women like 0, 1, 2, 3, 4, 5.
Yeah.
And then finding the respective probabilities and then finding the expected value of the X.
Yeah. So there are 20 employees, of which 8 are male and 12 are female, if I'm not wrong. We need to select 5, right? And we want to know how many female employees would be in that selection. So let's say my random variable X denote the number of female employees. So it's possible that I have 0, like no female employee, 1, 2, 3, 4, or all 5 are female employees, right? Now, similarly, like we have done such type of question in week 7, 8, I can find the probability that my random variable takes X 0 for 1, 2, 3, 4, and 5, right? You can easily compute that. And once I have all these values, you can simply find the expected value of X by plugging in it. Right? You will learn an easier method for finding the expected value of such questions, but that would be in week 11. So you will study that. But
Sir,
yeah, for now, we will go the long way. Yeah.
Sir, I got 2.96, but the answer is 3. That means my answer is wrong, right? Somewhere calculation mistake.
Yeah, somewhere calculation mistake might be there. Yeah. But that's very minor, right? I think within the range, your answer would lie, I think.
But
So
the
is
answer
following
is
this pattern only, even I got 2.996. I don't know why. Like
So I also got
2.996.
2.996.
Okay, 2.996. Yeah, it's more or less the same. You will get close to 3. If I,
but
it's
the answer was not in the range, it was the value 3.
the value
Yeah,
3.
it's
Okay.
round up error, maybe.
Yeah, the value you are getting 2.996 is because basically because of rounding it off, because it's possible that you might be rounding it off to 3 decimal place and then adding them all, right? So it could be one of the possible reasons, but actual answer is 3.
Yeah.
So we will study the easy way in week 11 also, right? So for now, just be aware of this. That yeah, that's how we can compute. But this question won't be very calculative. You will be able to do it even in 30 seconds.
So like in exam, if we get answers like this, and if they have not written like to some point value, then some decimal value, then we just directly round it off and write the value.
No, in quizzes you will always get a range. So if
Okay.
actual answer is 3, so your answers in between 2.95 to 3.05 would be correct.
Okay.
So such kind of calculation errors we do take care of. Okay.
Yes, sir.
Okay. Question number 4 also, I think it's the same way you can approach, right?
But sir, the calculations will be very, long in this for 20 mobiles.
For 20 mobiles, okay, let me just go through it. 1,000 mobile phones, 100 are defective. Okay, 20 mobile phones. Okay, yeah. So I think you can leave this question for now. I think we have moved some content of week 10 to week 11. So this question, after studying week 11, you will be able to solve this question in a better way, I feel.
So I guess
but so
if
we
we
can
take the
approach that question
probability,
in a different way, right?
yeah.
In
I
a
mean,
different way, yeah.
like
Sum
in
of
a
random
different way in the
variables
sense,
you can do and
yeah,
find
yeah,
that also. Yeah.
like taking one, like one case, like for 2,000, I mean,
Mhm.
calculating one case and then summing up, and then
Yeah,
the
that way
same.
also you
Like
can do.
I
Yeah.
don't know if we can.
Yeah, you can definitely do that. That's also an easy way.
So
So you
we
can
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 use
you tell that way which Sayan is mentioned? Can you please explain that way?
okay, let's do that. Okay, so he's saying that you will get a profit of 2,500 rupees, right? And you will lose 10,000 if your mobile phone is defective, right? Okay, so let me just write it down. This one. Okay, so I will define some 20 random variables in that. So your random variable one is, it can take value plus 2,500 if the phone is not defective, right? And it will take the value minus 10,000 if your phone is defective, right? And we know out of total 1,000 mobile phones, only 100 are defective ones and the remaining 900 are not defective, if I'm correct. Let me just check.
Yeah,
Right.
yeah, 100 are effective, and yeah.
So the probability that you will gain 2,500 is if you're selected one of these 900 phones, right? That would be 9 over 10. The probability that you will lose 10,000 is if you have selected one of these defective ones, right? So if I mention the probability part here, it would be 9 over 10 and 1 over 10 for it, right? So you can find the expected value of first phone. It would be 2,500 times 9 by 10 plus minus 10,000 times 1 by 10, right? You can compute this value. Now it would be same for all the phones, right? X1, X2, X10. For all the 20 phones, it would be the same. So your expected profit would be nothing but the sum of all those random variable.
Okay, got it.
And all have the same, right? So it would be nothing but 20 times this expected
20,
value.
20 times.
So you
So
can
the
easily compute that
shop,
way also.
the retailer got 20 phones. So out of that, if we multiply the probability of defective, then we'll get the number of defective pieces there. Then also we can find it.
Can you repeat? I couldn't get that. Can you
So
repeat?
the retailer is buying 20 phones, right?
Right.
So 20 into like 1 by 10 would give us the number of defective pieces out of those 20 phones.
Yeah. If you do that way, you will still get the same answer. It's just like you are pre-multiplying 20 and we are doing it at the end. So it would be the same.
Okay, sir.
Okay. Yeah. Okay. Yeah. Anything else?
Sir, I have just one question. Like the probability distribution and probability mass function or PMF, it's same because ma'am use it interchangeably in video.
Okay. Probability distribution and probability mass function. Yeah. So probability distribution function, we usually have two types, PMF and like probability mass function and probability density function. You will understand the difference between the two in week 11 and 12 mainly. But yeah, for now you can assume it's same. Yeah.
And means, can I ask a week 9 topic?
Yeah, sure. Yeah.
Week 9, I want to understand CDF. I don't understand CDF. PMF, I understand.
Okay.
Yes, in that, where to use it.
Where to use it? Okay, let me just write it down. Okay. Okay. Let's suppose your random variable can take, I will go by example. Okay. Let's say it can take only three values, 1, 2, and 3. And some probabilities again, P1, P2, and P3, right? But it's possible that your random variable can take some 50, 60 possible values also, right?
Yes.
So now suppose I want to find that x is less than or equal to 2. So what would it be? So whenever we need to find this, okay, so
1 and 2 is the only, means P1 and
yeah,
P2.
so it's just nothing but the cumulative probability of 1 and 2, right?
Yes.
Sum of 1 and 2, or cumulative probability, right?
Basically some addition of two
Yeah,
probability.
yes. So what happens is, generally, suppose you need to find the value of a random variable in between this value a and b.
Yes.
Okay, so what we do is, suppose this is the possible values, this is your value a, this is your value b, right? So okay, so what we do is, first we find all, like, what's the possible value that I get at most b, right? I get value less than or equal to b. It
Equal
would
to
be this
2.
region.
So it should be 2 only.
Now, if I generalize it in between a and b, it would be this,
Mhm.
right?
Yes. Greater than,
I
less
am
than.
getting this region extra, right?
Yes.
And this region I can subtract by subtracting the CDF at point A, right?
Mhm.
So having CDF helps you compute probabilities very easily within a range. So CDF is nothing but just a summing of all the probabilities up to that value.
Okay. Also, while I was preparing for this quiz 2, and I was going through this what we call conditional probability, I don't understand Bayes theorem, law of total probability,
Mhm.
and generally multiplication rule. There was one example where ma'am used that selection of cards from a deck of 52 cards, and for
Mhm.
each pile we have only one. So that was not very simple and straightforward. So how to understand, means the way or the framework that probability has, it varies based on the conditions. So means it is like we have to create events accordingly or anything different.
Okay, so the way ma'am did it, okay, was to make you understand the Bayes theorem, right? But there are, if you just look at the question and try it your way, like, it's possible that you might come up with an easy formulation for that. It is possible for that example. You can try that. Ma'am has done it that way just to give you understanding of Bayes theorem. And
Okay. Bayes
okay,
theorem in summary, I just understood that based on a given condition, we can't directly predict the probability. We
okay.
have to check at the values, means basically how this thing, for example, if we have 10 people who are working as a librarian, and there are means 20 people who are working as a farmer, then which is more likely to happen? We have to look at that also. That is what I understand with Bayes theorem.
Okay, no, Bayes theorem is basically we predict something about the past. Okay, let me just give you a sense of it. Okay, do attend it. Tomorrow's session. Usha ma'am will be taking it. She will be taking some examples, putting a framework for Bayes theorem and all that. Do attend it. Let
Where
me
is
just
the
give you a
revision
brief.
session?
Tomorrow 6 to 8. Usha ma'am will be
Yes.
handling it for week 7. Okay, let me give you an example. Suppose one person is at this point, okay,
Mhm.
and there are some three paths: path A, path B, and path C, right? And okay, let's make it a bit imaginary. Suppose there is some monster in each of these paths, okay, and
Okay.
there are there is 0.3, like 30% chances that you might not survive if you go by this route. Okay, 0.5 if you go by this route, and 0.4 if you go by this route, let's say, okay, and
Okay.
then again you come out at this route again. Okay, so now we know that this person went by this route, right? We don't know which path he has taken. Is he taken path A, path B, or path C? Only thing we know is he survived.
Okay.
Okay, he survived. So the event has already occurred. If you see that, right? He has gone through the path.
He has gone through
came
the
out survived.
path. Yes.
Yeah, he has came out survived. But now we are interested in finding out what are the chances that he has chosen the part 2.
Okay.
Okay, so event has occurred. I am interested about something prior of that event, right? He
Mhm.
survived is the major event, but before that he might have taken some route, right? I know my final result. I am interested in some in between step chances, like what is the probability that he has taken this route, given that he has survived already, right? So for that thing, we use this theorem generally when we know about the final outcome, but we are interested in something about getting the prior knowledge of that event.
Okay, so
So,
understood, sir. So means it is more of a previous event. Whatever
previous
has
event.
happened, based
Yeah.
on that we can find out means why it happened.
Yeah.
And law of total probability is from the conditional probability only. Just it is generalized to the all the settings of event, right?
Yeah.
Means E1,
Probability.
E2, E3.
Yeah. Okay. So if you look at this example, suppose these are the 3 paths, right? I have knowledge about each of the paths, right? Part 1, part 2, and part 3, right? And this circles tells me the event that he survived. Survived. Now I have knowledge about each of the path. Like if you go by path 1, he will survive with chances 70%, right? In path 2, he will survive by 50%. So what we do is we compute the probabilities because I have knowledge about each path, right? So I will compute first from path 1, then I will compute from part 2, and then we will compute from part 3, and I can add all of them and I get the total probability that he survived, right? That's why it's called law of total probability. Based on our knowledge about these 3, I can find what is required for each of them and simply add them to get my final outcome.
Actually, there are a lot of things means in this module, week 5 to 8.
Yeah.
Mostly it's more on permutation and combination, and then it moves to probability. But where we are using this permutation and combination and probability means in some of the questions I do, but in normal, where we are using this?
The permutation combination is used only to finding the probabilities, where you have to find your number of favorable outcomes, total outcomes. For that purpose only we use permutation combination. That's why it's covered in week 5.
In general, means what ma'am have given the example like 52 cards we have, or 6. 6 means in an outcome there can be max a 6 for a single dice roll. These are all means we can count that. Obviously, I used it in solving the graded assignment. And I think that graded assignment is, I mean, sometimes it requires a lot of logic and sometimes it's pretty simple. That is how the question will be in the examination. I have to work on that. This was the main query that I had. Okay, sir, I got it. For week 9, we are doing week 10, right?
Yeah, week 10. Yeah.
Week 9,
So,
I understood.
Week 9 and week 10 are nothing but the same. From week 9 to 12, it
random
will be the
variable
same
only.
thing.
It's based on totally on the random variable. Although I haven't watched all the lecture, but I have watched till lecture 2.
Yeah, so as per course structure, week 9 to 12, you will study the same things you studied in week 1 to 8, but in terms of random variable now. That's the only thing. Because in stats 2, you will, like, it will start only from random variables only. So assuming that basic things are all covered in.
Yeah, ma'am actually started with the inferencing, means how we can derive conclusions. Some of the lectures ma'am said.
Yeah, that would be the major part of statistics too, when you go there.
I think that week 10 is 16th, right? Deadline for submission.
Deadline for week 10
submission of graded is 16th.
Yeah.
Sir, can
Yeah,
I ask a
16th.
question from week 6 if all the things are completed?
Yeah, sure.
Week 6 practice assignment question number 1.
So let me just share my screen.
There are 30 students in the group. That one.
Okay, so I think we
Yeah, you need
will
to.
get new set of 5 questions. Do you remember the question
Yeah,
statement? Yeah, okay.
not this one. Maybe you have it in a different. Yeah. No, not this one.
What's the question statement? There are 30
This
students.
one,
This one, right?
This one.
Okay.
Yeah.
Okay.
Actually, up till 6 into 6 into 5. That I have actually calculated that. Okay. So there are 36 students, 36 seats total in total, and the total number of students are 30. So 2 students need to sit in the same row.
Okay.
So I have actually done that in 6 into 5.
Okay.
And this needs to repeat 6 times because there are 6 rows. So 6 into 5 into 6.
Okay.
And now I need to calculate about the remaining 20 students.
Right.
So this is P, but according to me it should be C. But like
why
here
it could be
in the
C?
question there is nowhere written that what should be the arrangement, and we generally do P in arrangements only.
Okay. Okay. Just answer this part. Okay, I will just write it down. Okay. Let's forget about 30 students. Suppose we have only 4 students. Okay? Only 4 students I have, and this first row I had 3 seats. Second also let's say I have 3. Okay. And let's say A occupies this seat and B occupies this seat. I'm fixing A and B over here. Okay.
No, I mean,
In
but
one
they
case,
need to sit in the same row.
okay, let's fix B there in that won't matter much, but let's say B here. Okay.
Yeah.
Suppose I fix C sits here and D sits here. Okay. And in second case, D sits here and C sits here. Are these two cases same or different?
Different.
Different, right? So
Yeah.
here, in which order they are sitting do matter, right?
Yeah, that is true. But in the question, they are sitting in how many ways they can occupy the seats.
Yeah. So these two are different ways of occupying seat, right?
Yeah.
In question statement, you won't always get the term arrangement. Sometimes you need to identify that, yeah, it's the arrangement question. That's why EM2 parts comes in week 5 and week 6.
No, that's what I'm just saying, that if these types of question are asked, we need to automatically assume that it is asked that we need to arrange, and then
Yeah, sometimes like in such questions, it is very clear from the statement that you need to do arrangement of these 30 students in
yeah. But
36
this
seats.
is kind of ambiguous.
I don't think so. It's ambiguous. It's just about you practice such question. It would be very clear. Try to go by EMQ approach. Try to identify the steps order matter or not. You will be able to get an idea of permutation combination. Because 34C28 is nothing but you are selecting 28 seats of the 34. But I also do need to arrange the students on those 28 seats, right?
Okay,
Only then I will get the mess. Yeah. Okay.
Hello, sir.
Yeah.
Sir, I have a doubt related to exam city change. Yesterday I tried, but due to some network issue, I couldn't update it. And now I do have a small baby, and I mailed yet today to the support team to change my exam city. Is it possible, sir? For
Support
end-term
team will
exam.
support team will respond to you on that. You have mailed them, right? They will
Yeah, I have
respond you.
mailed it for the end-term exam.
Yeah, they will mail you. They
Sir,
will
it will get changed, no, sir?
only
Yes.
they can answer you better on it.
Oh, okay. Thank you very much.
Yeah.
So can you explain that constant multiplication thing now?
Constant multiplication in
As in like the question that I was asking, like minus 2 into x, it wasn't it wasn't like 4 into expectation of x, but rather like 2 into expectation of x.
okay, it was in practice assignment, right?
Practice assignment, yes, sir.
Minus this one, right?
This one, yes, sir. There's one more like this where they're multiplying it with 20, but the same concept is being applied.
Okay, so here we are finding expectation, right?
Yes, sir.
So what is the expected value of ax plus c, where a and c are constants?
So
A
a
into x
square
plus c.
into expectation of x.
It's not a square, it's a times
A
expectation
into
of
x
x.
plus c.
It's a
Okay,
times here.
and if we are taking just expectation of ax, then
Okay, in that case your c would be 0, right?
yeah, there's no c, like there's no constant, just this.
Yeah, in that case it would be a times expected value of x, right?
Then there's this property where they say that if constant is multiplied, it becomes a square. Oh, that's in variance.
That's in variance.
Thank you, sir. Thank you, sir.
Okay, so it would be a square times variance of x. So in variance in general, if you add a constant, it adding constant doesn't affect. In that case, it still
It
remains the
changes.
same.
Just squares it.
Thank you, sir. I was confused between these two.
Okay, yeah. Anyone, anything else?
Sir, just a thing, just a small query. I mean,
Okay.
it was a question in a practice assignment again, and
Okay.
I totally have the chart or whatever that was given. It was some lottery question kind of question, and 0, 4. I mean, there were ranges and all that. I calculated everything, but one question is there. Like there are some basic mathematical notations over there that I totally understand. But whenever like we are calculating, let's say 1 less than x less than I mean sorry, 1 less than equals to x less than equals to 700. So we are taking 700. So we are actually calculating both the endpoints. Yeah, this one. So, sir, for the first part, it would be the probability of the first case into 0, and
Yeah.
then will be probability of the second case into 4 plus, and we are gonna do that till we get the last thing. So, sir,
Right.
the question is, here we are including endpoints. What if we are not including endpoints? Let's say there is nothing given there. So, for the first case, what values we are gonna take? That's my question. Because for
Okay,
the
so
second, third, fourth, those are clear. So for the first case, what values we are going to take if the including both endpoints are not given over there?
including both endpoints means it's not from this perspective. It means that all possible numbers you have on ticket is 1 to 1000. Okay, so what happens is when we write between 1 and 1000, there is a lot of confusion whether we need to include 1 or 1000 or not. So that's why we specified it that you need to include both of them. So it means total possibilities is 1000, right? 1000 C1 because you have
Yes,
only one ticket. So for the first case, if you get any number between 1 and 700, both inclusive again, so in that case, your favorable outcomes are those 700 tickets, right?
Yeah.
Probability would be 700 by 1000.
7,000, yeah.
For the second case, you get it from 701 to 950, right? So that would be those 250 are your favorable cases.
250 and total are 100. Sorry, 1,000.
250 over 1000 would be the probability that my random variable takes value 4. Similarly, for 1000 and 1000 you can compute, right?
So, sir, the point is, I mean, including both endpoints, that doesn't concern the answer of the question.
Yeah, it doesn't concern. Yeah, it's just to give you a clarity that both are inclusive. But sometimes many of you may come and say between 1 and 1000 does not include 1 and 1000. Just we added that thing in brackets.
Oh, okay, sir, got it.
Okay, yeah. Anything else? Or shall we wrap up for today?
Sir, when I will
Yeah.
solve, suppose I haven't solved all the questions here, but
Okay.
once I solve this week 10, maybe
Mhm.
2 days later or 4 days later, when can I ask all these questions if I have doubt related to week 10?
Okay, so are you added on the Telegram group? We have been informed about
No,
on-demand
sir, I am
session.
not on Telegram group. I am only on Discord.
Okay, so we have shared the link for that group also, right? So you
No
can.
mail, actually, I haven't received any.
Yeah, that we are not, sometimes we are not able to go into, I mean, I was not able to go into that actually. I tried once and I left it.
Okay. So it's not like we had only one. We will be doing it. Like in a week, we would doing 2-3 sessions, and it
I
will be
generally ask
mainly focused
questions
on.
on Discord, and apart
Mm.
from that, I don't know where to ask because week
Okay.
11 is released today, and week 10 means actually I am delayed by 1 week, maybe due to this exam preparation or anything. But
Mhm.
I just want to ask questions. I have multiple questions.
Yeah, you can ask it in other sessions also, or on-demand session would be more focused on it. I have
On
pinged the
demand session, I know, but it is not being displayed on the calendar. Means
it is
I don't
displayed on
even
the
get
calendar.
notified about this all things. Today also I came here because someone told me that today is some session.
Okay, I think you might not have added calendar to link the on
Actually added
course
it,
calendar to it.
but somehow it's not showing. I have only access to this student calendar, not the course-wise calendar. I already see that, but I
Mhm.
don't see any means, event happening. Means I have that color coding, everything
Mhm.
enabled, even that everything like subscription and everything, but I can't
Mhm.
see it.
Okay, just let the support team know that they will guide you on how to enable it.
Okay, sir.
And I have pinged you the Telegram group channel on the chat box, so you all those who haven't joined can join that also. On
Okay.
Monday we will be having one session. So but by now we have done I think 2 sessions on week 5, 6. So we'll be having further
Sir,
more.
but it's not opening. This Telegram group is not even opening. If you can just share the name of the group, then I will search it through Telegram.
I just joined with the link.
I think this is the invite link only. You will be able to join. Just
It's
try
not
again,
working,
save
sir.
this.
It's not working. I actually opened it on the browser.
Thanks, sir. Just now I joined.
It should work. Okay, just save the link and try again in some time. You will be able to join it.
Try to copy the
Okay,
link
sir.
and join it with your smartphone if you can. It would be easier.
Yes, sir. We can join through the link. Thank you, sir.
For confirmation, I have just joined.
Okay, great.
Okay, sir.
Okay. Okay. Anyone? Anything else?
Sir, 10.2 question number 5. Just explain it, sir.
10.2 question number 5. Okay. Question number 5. Okay. Expectation of random variable is always one of the possible values, or is it? Okay. What do you think about it?
I think, sir, exceptional. Always, if I get, if I thought always random variable, sir.
Okay, let me just show you. We have discussed it today only.
I joined late. That's why I'm asking, sir.
Okay, so suppose my random variable takes value 1, 2, and 3. Okay.
Okay,
With
sir.
probabilities P1, P2, and P3. Right?
Yes, sir.
So do you know what does expectation tells us?
No, sir.
It tells us about the long run average. Long run average means if I keep on doing that outcome infinite number of times. Okay. So
Okay.
suppose I did it first time, I got the value 2, then I got 1 3 times, then I got 3, and I got, like, if I keep on doing it, I will get multiple other values, right?
Right.
Among these 3. If I average all these values,
Okay.
the value which I will get is the expected value. So the
Maybe.
long range average might not necessarily be one of the values. It can be any value in between also, right?
Yes,
Like
yes.
here we got 1.56. So that's what.
No. Okay, sir. Good. Next.
Okay. Anyone, anything else?
Sir, just another question. It's again in practice assignment.
Okay.
I just want to know if we can approach that question in a like like if there's any shortcut or kind of, because I took a long process. It was like 4 fair coins are tossed, and yeah,
Okay.
and we need to find the standard deviation of getting ahead. I guess that was the question.
Okay.
Yeah, this one, sir. This one. So, sir, what I did, I mean, it was kind of hard to structure the sample space. I mean, the combinations. So after that it was a cakewalk. So, I mean, without doing that, can we approach that question in any other way? I mean, just structuring the head, that combination. I mean, those combinations. Otherwise, can we approach this question in a different way? Because see, sir, time is something in the examination.
So, in here, then we will be having 32 possible cases, right?
Yes, sir.
Yeah. So you have already studied permutation combination in week 5, 6, right?
Yes, sir.
So x equal to 0 means you should have tail in all the 4 outcomes.
Yes, sir.
It means there is only one way, right? On the first toss, you should have tail, only one possibility. Second, also you should have one tail, 3 and 4, right?
Yes, sir.
Now x equal to 1 means you should have
So
only
one
one
head.
head among the 4. So on the any of the 4 places you can have head, right?
Yes,
so
sir.
for the heads you have 4 places, 4 options, right? And on the remaining 3 places you have only one way. It should be tail, right? So there are only
Yes,
4
sir.
ways in which your x will take the value 1.
Somebody is disturbing, sir. Mute, sir. Please mute everyone.
Okay, good. I think they have muted, yeah. Okay, if I okay. Now for x equals to 2, I have 4 of these, right? Now select.
Yes, sir.
Now I need 2 heads, right? So on any of the 2 places I can have heads, right? So in how many ways can I select 2 places of these 4? 4C2, right?
4C2. Yeah.
4C2 means now I have 2 places for head and remaining 2 for tails, right?
Yes, sir.
Number of ways I can fill this is only 1 because I have to fill head in that, right? And for these
Yes, sir,
2,
that's true.
again 1 I have. So there are 4C2 means there are 6 ways of getting x equals 2, right?
Yes, sir.
Similarly, for x equals to 3, you will have 4 ways, right?
Yes, sir.
So 4C2 6, right? Head, tail. Head. So let me just head 2, 3. Okay, and the 3. Yeah, I think it should work. Similarly, for x equal to 3, you can find, right? And similarly, for x equals to 4, you will have.
X equals to 4. Yeah.
So that way you can easily, like instead of writing all the possible values, you can do it.
Oh, okay. So the position factor I need to check over there.
Yeah.
Which position? Okay. Got it. Thank you.
Okay. Yeah. Anyone, anything else?
Thank you, sir.
Okay. Thank you, everyone. See you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.